Hi everybody, and welcome to the first actual proper class that's part of Biodiversity and Sustainability, WATS 1200. Today we're going to be talking a little bit about what the class is about, what it involves, what I expect from you, and what you should expect from me. Before we start, a couple of bits of housekeeping. One, yes, I do own more than one shirt. I just recorded this section straight after the last one, and we might get disturbed in this by my little dog. His name is Mr. Goose, and at the minute, I'm the only one in the house, and so I'm having to keep an eye on him at the same time. Can't really leave him on his own, and he does like to get involved, but he's very cute. He looks a bit like a Fraggle, so say hello. Righty. So let's get started. This class, there is actually a presentation involved, so I'm just going to start sharing the screen. So make sure we're on the right desktop. There it is. Okay, you should now be looking at a PowerPoint presentation. Okay, so we're talking about biodiversity and sustainability. My name is Ed Hamill. My office is in the BNR building. Not that that's any great sort of import because no one's really there at the minute. But even though I'm not going to be in my office, I am going to be holding office hours for this class. These take place between 9 and 10 a.m. on Thursdays, and there will be a Zoom link for it that's up on Canvas. I will just leave that Zoom open, and if you want to come and say hello, that would be great. If you want to contact me directly by email to arrange another time or just ask any questions, my email is ed.hamill@uoxu.edu. And a bit about me, my research. So I don't know how much you know about what professors actually do, but my job, I'm not a teacher. I'm not like your high school teachers who their entire job was just to teach. My job, only 40% of my time is supposed to be spent teaching. It's only a minor part of my position. I'm actually what they call research faculty. So to break down my time, 50% of my job is allocated to actually conducting primary scientific research. I'm going to give you an example of what some of my papers and projects are. So one of the biggest projects I've done since being here at USU is I did a very large analysis in the continent of Africa, looking at the relationship between high levels of biodiversity and conflict risk. What we found is, as shown in these two maps here, this map on the left, this map here on the left shows the amount of biodiversity richness present in different parts of Africa. This map on the right shows the risk of conflict that we calculated based on history of conflict in different locations in Africa. What you can see, unfortunately, is these two line up really well. So the areas of high biodiversity are also areas associated with high levels of conflict. What I did was, first of all, found out this relationship exists, and then secondly, started to say, okay, well, given this relationship exists, what impacts does it have on conservation, and how can we still do conservation even though we've got high levels of armed conflict? If you're interested, there is actually, I did give a TED talk on this project a couple of years ago. I will put this link, a link to this TED talk up on Canvas as well. So in addition to this part of my research, another part of my research I do is actually looking at population community ecology and how changes in the current state of the planet are affecting biodiversity at the community level. The biggest flagship project I did from this was actually based out in Australia, and it was looking at how changes to ocean chemistry, like ocean acidification, which we'll talk about later in this class, actually affect communities and more specifically affect the ability of jellyfish to hunt. And so I did this big project, and we basically showed that because of changes in the ocean chemistry due to increased amounts of CO2 in the atmosphere, jellyfish are actually becoming much better at collecting their prey. This project was featured in The Guardian, along with a few other news outlets, and they did an interview with me and we talk about what do jellyfish teach about climate change and things like that. So it's been a big part of my work. In addition, most recently, I've been doing a project out in Costa Rica looking at mosquito distributions and how mosquitoes evolve a very serious resistance to agricultural pesticides. And as a result, spraying for agricultural pesticides to remove pests is actually increasing mosquito numbers in some parts of Costa Rica. And that has implications for human health. These mosquitoes carry malaria, they carry dengue fever, and they carry Zika. So as a result, it's quite important stuff. So I just wanted to highlight the fact that even though I'm teaching you a class, the majority of my job is actually conducting primary research. Teaching is a minor part. It's a part I think is very important, and I do take it very seriously, but it's not all of my job, and a lot of the time I'm actually conducting proper sort of scientific research, as are all the professors that you'll get at USU. So although we can't do clickers, I thought I'd do virtual clicker questions. So what I want you to do in each of these is just think about how I feel, what your answer to this question would be. So in this first one, I want you to know about how I feel about taking this class. Just think about which of these is best for you, and think about how that might affect, which of these options best describes you, and how that might affect your progress going forwards. And okay, so I'll move on. So now let's go through the logistics of the class. First of all, the syllabus. The syllabus is the first place you should go whenever you've got questions about the class, or when you should be thinking about how far along in the class should I be, what stage should I be at, and things like that. Also, it's very important, this class does have course policies, so please make sure you're up to date, especially with respect to plagiarism and cheating and naughty little things like that. So just make sure you're up to speed on it all. The good news about this class when it comes to acquired materials, there is no textbook associated with this class. I understand that college is expensive and textbooks can be very expensive, and many of you are not science or natural resources majors, so I didn't want you having to spend upwards of $100 on a textbook that you would potentially only use for one class and then you wouldn't touch again for your whole university career. So as a result, there's no textbook. Instead, all readings that are needed for this class, I will make available on Canvas and I'll provide to you. Okay. The evaluation. So this is how it stands at the minute. Depending on how we work due to the COVID restrictions, some things might change a little bit, but this is the general idea. So there's 300 points in total for this class. 75 of those points are due to independent quizzes. We do a whole series of independent quizzes. Each quiz is worth 15 points. Your score on the lowest quiz is dropped. So if you make a complete bum of one of them, or for some reason you end up missing one quiz, your lowest score is dropped and it doesn't count, okay? Then we also do group quizzes. These are worth 5 points each. None of them are dropped. You will do these quizzes together and we'll sort of go through the logistics of that later. Then we also have homework assignments. 20 points this class, which is a large amount, is a debate. I will give you your debate topics. I will put you in your debate teams and you will go backwards and forwards and we'll talk about a debate, a sort of topical biodiversity or sustainability issue. We also, as a group project, do a poster presentation. This is where you as a group get together and you produce a poster based on some aspect of biodiversity or sustainability that you find interesting. And then, of course, there will be a final exam. Okay. So there's no real extra credit in this class, which is important. So it's a big class. It's very hard if you're trying to give extra credit to people. To get an A in this class, all you really have to do is participate, be timely and thorough. The main reason that people fail this class, and a few people do fail it has to be said, is because they don't keep up to date on the work. They either miss quizzes or they miss homeworks. Nobody has ever missed 2 assignments, so 2 quizzes or 2 homeworks, has ever missed less than 2 of those and got less than a B. So pretty much based on the history of this class, if you turn in every quiz and you turn in every homework, you're going to get a minimum of a B. On the flip side of that, the people that did fail this class had not turned in at least on average 5 homeworks or quizzes. So just turning things in gives you a really high chance of doing well in this class. Okay, so my teaching approach normally is very active learning. Unfortunately, that can't be done nearly as much as I would like with the COVID restrictions, but there's expectations about the class still remain. So my expectations of you are just please keep up with the lectures. Don't leave everything right to the end because it won't work because there's continual quizzes and homeworks that need to be handed in. Make sure you complete your assignments and readings and make sure you participate in the debates. Your expectations of me should be, well, first of all, provide an environment for learning and success, maintain an organized class structure, give you clear requirements and provide feedback. If you think at any point I'm not doing those to the level that you expect, please let me know and please stay in touch and I can ensure everything is as good as it can be. So the teaching approach, there is group work in this class. The groups are pre-assigned, but only 25% of your total grade is direct group work. By and large, people have done very well in the group work overall. In addition, the group members do provide a little bit of peer evaluation. So this is going to be the general schedule of topics for this class. I've broken it down by weeks here, and I would really recommend you doing this a week at a time. Even though we can't meet for sort of formal lectures and things like that, keeping up to speed in this class is really beneficial for you, and it also means you're not missing out on any of the homeworks and things like that. So in this first week, we're going to do, the modules are going to be looking at this introduction, and also we'll do a little bit about graphs. The reason we talk about graphs is because graphs are very, very important for you to be able to interpret actual scientific data for yourself. Graphs are a clear way in which raw data and raw information are often presented. If you can read graphs effectively, and in some cases actually produce good graphs, it means that you are able to digest raw information and come to your own conclusions about what's going on. If you can't interpret graphs, you're relying on other people to do that interpretation for you and just telling you what's going on. And that's a very easy way for people to sort of influence you in ways that are not overly beneficial. In addition, if you can produce your own graphs, it means you can rapidly and easily communicate ideas. In the second week, we'll talk about measuring biodiversity. We'll talk about diversity at the genetic level, the species level, and a whole series of other things. In week 3, we talk about the importance of biodiversity, and we talk about the spatial distribution of biodiversity, both across the globe and also some of the factors that affect that distribution. In weeks 4 to 6, we talk about temporal distribution of biodiversity, so biodiversity through time. We talk about mass extinctions, which are my favorite lectures of all. I think it's great. And we also talk about the processes controlling biodiversity. From here, we then go into ecosystems, what an ecosystem is, how it functions, what it provides, what it needs to keep going. And at this point, the class sort of moves from being biodiversity focused to sustainability focused. And we start talking about, okay, the sustainable management of biodiversity, what does that mean? We talk about the threats to sustaining biodiversity, and right at the end of the class, we talk about sustainability issues. So this first section, it's well worth getting this into our heads. What is biodiversity? Biodiversity is a phrase, a word that gets bandied around an awful lot. You've probably heard it in numerous things. It gets thrown up on the news, it gets in media. You'll hear people talking about, we must do this to conserve biodiversity. Oh, we can't do that, that's bad for biodiversity. Oh, we need these biodiversity, we need the ecosystems to function in such a certain way, and that helps biodiversity. So you hear this word, but what actually is it? So let's have a bit of a think. So what I'd like you to do is just have a think in your own head. It's not marked, this isn't a quiz. What is biodiversity? So is it A, the number of animal species in the ecosystem? B, all species in the ecosystem, so animals, plants, fungi, bacteria, protists, all the rest of it. C, the number of species in an ecosystem and the processes they undertake, for example, photosynthesis or decomposition? Or is it D, the number of species, the processes, and the chemical composition of the ecosystem, e.g. water chemistry? So I'll just give you 5 seconds. 5, 4, 3, 2, 1. Well, Well, the actual answer is C. Biodiversity is the number of species in an ecosystem and the processes they undertake, such as the sequestration of energy from the sun through photosynthesis, or the breakdown of organic matter in decomposition. So just to reiterate, when we talk about biodiversity, it's biological diversity is the variety of life, and critically, its processes, what that life does. Okay, and we think about the importance of biodiversity and sustainability. Well, if we look at the UN Millennium Development Goals, this is a thing that was put out by the UN that's meant to cover exactly what we want the globe to be achieving in this period between 2011 and 2020. So if we look at what they want the globe to be achieving, it's got all these things like, well, we want to, number one, we must eradicate extreme poverty and hunger. Then we must achieve universal primary education, improve maternal health, combat HIV, AIDS, malaria, and other diseases. Didn't age so well. And then, but number 7 is ensure environmental sustainability. So this is one of the UN is obviously one of the most powerful bodies in the world. And it set out these development goals of how they want the planet to move forwards. And a major one of these was ensure environmental sustainability. And within this goal, number 7, they highlighted these 2 things they needed to do. So goal 7A was integrate principles of sustainable development into policies and reduce the loss of environmental resources. And goal 7B was specifically reduce biodiversity loss. So this was a major goal of the UN. So then after we think about why sustainability is important, let's have a think about what the number of described species by major group of organisms. This estimate, unfortunately, is a little bit out of date, but it's still relatively close. This is just describing the number of species by major group of organisms, and these are species that have been described. So they've been identified. Someone has gone out and picked out a species and said, okay, that is this particular species, and named it critically. When we look at the total number of species on the planet that have been described, we're looking at a number of 1,729,460. Now, this does sound like a lot, which it is, but what's really interesting is if you look at this number, 1,729,460, the vast majority of described species are invertebrates. And not only they're invertebrates, but they're insects. Over half the species on this planet, and that's everything, mammals, reptiles, amphibians, plants, fungi, protists, everything, most of them are insects. So insects are by far the most diverse group. But this is the number of described species. So what's the estimate of the total number of species that have been described and haven't been described? Well, the actual number of species is very much unknown. The best guess is an estimate of about 7 to 10 million species. Species are still being described all the time. So there were 2,500 vertebrates, that's mammals, amphibians, reptiles, and fish. 2,500 vertebrates have been described since 2009, the last 11, 12 years. And in some cases, in some very obvious places. So for example, the Gorgonian octocoral. This was described off Californian waters in 2019. So it's a new species of coral. This is a group of organisms that gets a lot of attention. And it was identified in the most populous state in the United States 2 years ago. Some of them are actually really kind of cool. One of the most interesting one that's come out recently is Cerebellus wakanda, or the vibranium fairy wrasse. Anyone that's a fan of the Marvel Comics franchise, you might suspect that the person who described this fish was a fan of that as well. They named it Wakanda, and they put vibranium in its title because it was from Tanzania, the part of Africa where Wakanda is allegedly nearby. And it is this absolutely beautiful fish. So that's a little bit about biodiversity. What is sustainability? Biodiversity is a word that gets bandied around an awful lot. It gets thrown around and used for this, that, and the other. Sustainability, I think, is a word that's misused even more. So you might have heard, oh, this particular car is more sustainable. You've got to use this fabric softener because it's more sustainable. Like, what does that mean? Well, the most succinct definition of what I think sustainability describes sustainability, especially with respect to biodiversity, is this expression here. So it says, sustainable actions meet present needs without compromising the ability of future generations to meet their needs. So what it's basically saying is sustainable actions are things that we can do today that help, that we need to do, but we do them in such a way that means we can do them again in the future. So for example, we can generate energy in such a way that means future generations can also generate energy. So something like that would be, solar would be a great example. You can generate, solar power is a sustainable energy because you can slap some solar panels on your roof, you can use those to generate energy, and in the future, later generations will be able to put solar panels up and they'll be able to generate energy just as well. That isn't the case for something like oil or gas, because even though you might be able to take oil and gas out of the ground and use it to produce energy, the fact that you are doing that is A, polluting the environment, so making things worse, but B, you're using up that resource. Other people can't use that resource because you've used it. So that's, I think, the best definition. However, there are so many definitions of sustainability. Some of them are just absolutely impenetrable. The one at the bottom, I would like to really draw your attention to. I don't want you to read these all the way through, but the one at the bottom is written by an economist. And scientists like to have this idea that the best scientists should be able to explain difficult scientific concepts in a way that's accessible to the most people. You should be able to, without overly simplifying them, you should be able to explain a scientific concept while in a way that anyone, a layperson, can grasp. Economists seem to go totally the other way. The best economists seem to be the ones that can explain a simple concept in the most complicated way possible. And there's an example of this here. So this is written by an economist, the last definition. So although the environment has been abstracted from by standard economics, the concept of sustainability has been recognized and incorporated into the very definition of income as the maximum amount that a community can consume over some time period and still be as well off at the end of the period as at the beginning. Hicks. Being as well off means having the same capacity to produce the same income in the next year, i.e. maintaining capital intact. The criterion of sustainability is thus explicit to this Hicksian definition of income. So I understand all the words in that little paragraph, but I don't understand them in that order. So sustainability, sustainable, it gets banded around all over the place. The most bizarre definition of it I ever came across was when I was working in Australia and I did a project with the Sustainable Minerals Institute. So a group out of the University of Queensland that focus on mining. And they came and approached us. I worked in the conservation department because they wanted to sort of talk about conservation. And I was like, oh, well, they've got sustainable in their name, so that's a good thing. But it turned out their definition of sustainable was very different from my definition of sustainable. My definition of sustainable is meet your needs today without impacting the ability of future generations to meet their needs. Their definition of sustainable was make as much money for as long as possible. So the most sustainable mining operations are one that allowed you to make the most profit for as long as possible. So we were total loggerheads there, to be honest. Now you'll see this Venn diagram come up a fair bit. We talk about this idea about what is something sustainable. Well, the ideal one, a sustainable action should be incorporate a social, an environmental, and an economic component. The only definition the only aspect of the definition of sustainable that I go to most often is the fact it's very what we call anthropocentric. So it focuses on people. Saying something is sustainable because it allows you to meet your needs today without impacting the ability of future generations to meet their needs means that by definition, you're only talking about people. You're not talking about sustainability of is this ecosystem sustainable on its own in such a way that it the ecosystem stays intact forever. It's a bit too anthropocentric. This Venn diagram incorporates the environmental component as well. Okay. So we're going to continuously refer back to the environment and biodiversity, represented by this whole bit at the top. Biodiversity and sustainability. So biodiversity affects sustainability. Sustainability affects biodiversity. There's a big concept in ecology generally that shows that biodiverse ecosystems are generally more sustainable. If you have a higher amount of biodiversity in an ecosystem, it's more resilient to change, it's more resilient to stress. So a biodiverse ecosystem is more sustainable, and a more sustainable approach increases biodiversity. The two are intrinsically linked. Okay? So just to reiterate this, so one of these things here, what do we mean by sustainable in an ecological sense? So now we're not talking about anthropocentric, we're talking about ecology generally. So what do we mean by sustainable? Is it A, the species and processes in an ecosystem continue to be present in their current state? We can harvest a certain amount of one ecological product forever. We can generate the most profit by harvesting a product at a certain rate for a certain length of time. Our car has good gas mileage, or E, all of the above. Remember, now we're talking about it in a pure ecological sense. Well, I think you could make the case for several of these answers, but I would say that if we're looking at a pure ecological sense, the best answer is actually A, because this is the only one of these options that is not still anthropocentric. All we're saying in the ecological sense is the species and processes continue to be present in their current state. One thing we have to remember when we're talking about sustainability is that in many cases, these ecosystems are perfectly happy just to continue on existing without any input from us. The rainforests of Central America, of Africa, of Australia, and of Asia were present for hundreds of thousands, in some cases millions of years before people even arrived on the planet. They were sustained and they were perfectly sustainable, they were perfectly happy for a very long time. Okay. So just one last thing I want to think about is, and if you want to actually send me an email on your personal view on climate change, I do like to keep a record of this. It's interesting to watch it change over the year. So just think about, what is your personal view on climate change? So A, climate change is human caused and a big problem. B, the climate is changing. It is human caused, but not a problem, or it's worth the benefits. C, the climate is changing. It's not human caused, it's natural, and it's not a problem. D, there's not enough evidence to say if the climate is changing. E, the climate is not changing. The whole idea has been made up. Just think about which one of those is most fits your worldview at present. Okay, so just a quick summing up. So by the end of this class, students should be able to, 1, define and relate the concept of sustainability, and recall the number of species that exist on Earth. Okay, so that is the end of this class. Thank you, and I will see you next time. All the best.